It's more New Wave Post-Punk Security Hour. Coming up, the talking heads inspire threat modeling as you may ask yourself, what is that beautiful app? You may ask yourself, where does that input go to? And you may ask yourself, am I root? Am I wrong? And you may say to yourself, my code, what have I done? Which means, this week we talk with Ankur Shah from Prisma Cloud about some practical strategies for bringing tools and teams together to deal with AppSec challenges, both in code and in the cloud. In the news segment, are AirTags on a road to nowhere? Qualcomm modem mayhem, Kubernetes maturity model, the wild life of ... XM vulns burning down the house, and more. Let the days go by, and stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Are you looking for a solution to protect your web apps against the most business-critical security vulnerabilities? Unleash the power of automated ethical hacker knowledge with Detectify for continuous coverage and relevant security vulnerability findings. Upgrade your web app security with speed and scale and start a 2-week free trial at securityweekly.com/Detectify. Go hack yourself. When it comes to web app and API security, the choice is simple. You can choose Fastly's security solution that teams will actually use in full blocking mode, just like 90% of their customers. Or you can stick with costly options that you probably just turn off. You can get Fastly's all-in-one platform that protects apps everywhere they live, however they're built. Or departments can agree to disagree. You can go to securityweekly.com/Fastly to learn more. Or you can just wish you had.
MediaOps presents DevOps Connect, May 19th at RSA Conference. Christopher Krebs, former director of the U.S. Cybersecurity and Infrastructure Security Agency, will keynote in a live fireside chat with host Alan Schimmel, which will also include Q&A with the audience. Besides an exciting keynote, you can also attend 30 other sessions featuring a powerhouse lineup of DevSecOps experts. Sign up for this free event now.
This is episode 150, recorded May 10th, 2021. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
Oh, hey, hi. Sorry, I was just working on getting you a recording contract for all your intros.
Thank you, I appreciate it. As you're doing that, you also should think about staying in the loop on all things Security Weekly. Visit securityweekly.com/subscribe to subscribe on your favorite podcast catcher or our YouTube channel. Sign up for our mailing list, join our Discord server, and follow us on our newest live streaming platform, Twitch. In our next technical training webcast on May 13th at 11 a.m. Eastern, see how attackers gain access to endpoints and learn how to use defensive strategies to protect against those attacks. In our May 27th webcast at 11 a.m. Eastern, we'll explore the latest attacks against DNS. Oh, it's always DNS. And the latest techniques that make it possible to discover and disrupt attacks. Then join our webcast on June 3rd to learn about pen testing tools and why every organization should be using them regularly. Register now at securityweekly.com/webcasts. And if you missed any of our previously recorded webcasts or technical trainings, they're available for your viewing pleasure at securityweekly.com/on-demand. Ankur has spent 16 plus years bringing innovative security, collaboration, and virtual technologies to market. He's passionate about building products from the ground up into market leaders. He joined Palo Alto Networks through the acquisition of Redlock, where he ran product management for securing public clouds. In his current role as a VP of products, he's responsible for driving product strategy, roadmap, and execution for public cloud security. In his previous role, he built and led go-to-market efforts for the CASB solution at CipherCloud. Ankur has also held leadership positions at Symantec, Citrix, and Cisco. Hello, Ankur. Thank you for joining us.
Hey, John and Mike. It's so good to be here. As somebody who runs a podcast as a hobby on weekends, it's so good to see you guys in action. It's like seeing how big leaguers operate. So super excited to be on the other side and looking forward to the conversation.
Well, thank you. Well, thank you for coming on a Monday morning, at least for some of us, to to chat. We'll see how we can keep things going before the coffee rolls off. But in terms of being dynamic, there's also an interesting dynamic in cloud native apps. On the one hand, we have code being released on a frequent basis, but that code is also not just about the application layer. That code now is about infrastructure. Infrastructure is code, of course. So we have here kind of this specialization in tools as well as knowledge, and applications becoming more complex. So just to kick things off, what are some of these characteristics of modern applications that makes it so hard to think about what do teams and tools need to do to come together to make things secure?
Yeah, it's a great question, Mike. Kind of just taking a step back a little bit, there's a reason why application security is right now, as of 2021, it's like a $4 billion market, slated to become 16 billion, 25% CAGR over the next 5 years. And the reason for that is that applications continue to be the number one security threat vector. And we'll talk about like why that's the case. But I think to your question, why is AppSec so different today, or it should be so different today than it used to be thought about in the past? And the biggest reason is obviously the modern applications are fundamentally different. Back in the days when I was a developer, it seems like many moons ago, I would write my code and then every 3 months, check it into our centralized code repo. And then somebody would run and then it gets deployed in production. The build and release managers, those used to be, separate group of people, deploy the application in production. Then you run a scanner, takes days and days. And then, we ship it to production. Things have fundamentally changed, right? Everything within an application is now completely compartmentalized through microservices. So you can, ship applications on demand. We have customers who are shipping this on a daily basis, right? And individual components that make up the application can be shipped on demand whenever, they want as part of the CI/CD pipeline. So this makes it really, really difficult for security teams, especially if you're using the traditional security approach, to really kind of rein things in. So, to answer your question, it's the microservices, it's agility, it's allowing clouds, it's the velocity that's fundamentally so different in modern applications than it used to be, just like 5-10 years ago.
Yeah, and it seems like, too, it's not so much, if I'm going to go into a little bit of electrical engineering, perhaps, we're not so much in series anymore as we do build, test, security check, the release, et cetera. It's a bit more parallel because you are also hitting a couple aspects there too about what are the components that go into the code, meaning software dependencies, things like SCA, as well as what about the code that we're writing, as well as the cloud that we're trying to secure. So that's pretty interesting that not only have you pointed out things have changed, but there's a lot of different ways that those applications can be attacked too. We've gone far beyond just the simple SQL injection cross-site scripting. There's a lot of more fundamental, interesting things that we've seen. What do you see out there? What comes to you as major concerns for AppSec?
Yeah, so, as it pertains to application security, really there are just at the highest of high level, right? Like we have to think about two sort of fundamental things. One is the application itself and how do you secure it? And the second part is that where the applications live. Applications just don't live in isolation, right? Like they're part of an infrastructure layer, call it IaaS or PaaS layer. So you have to make sure that the things that make up the application is protected, and the things that the applications live inside, right? Like your compute, your infrastructure, got to be secured as well, right? Like both aspects. On the first one, right? Like I think you alluded to this. The things that make up the applications are nothing but a whole bunch of open source libraries, code, etc. Once again, just going back in the memory lane. Back in the days when I was a developer, it was like sort of 80% my code and 20% open source library. But things have changed now. If you really think about open source has kind of taken over the world. I mean, open source is vulnerable as it is pervasive, right? Mm-hmm. From the last year to this year, there has been a 50% increase in open source code as part of the modern application software because, nowadays developers love it, right? Like why build it when it's available freely? So as it pertains to protecting the application, you want to make sure that the open source libraries that make up the applications or images don't have vulnerability. You want to then make sure that as it goes into container repo or your repo where your images live do not have vulnerability. So that's the thing inside. As far as the things that applications live in infrastructure, you mentioned something called infrastructure as code, IAC, which is I liken it to RNA, right? Like which is it is not the thing itself, but it gives you instructions on how to sort of build that thing. So in this particular case, infrastructure as a code contains the instruction set in terms of what type of infrastructure to build where the applications will live. So you want to make sure that you're protecting that as well. So basically two big areas of security. And then you want to think about protecting both of these areas across build, deploy, and run. So it's sort of like 2x2 dimension. Protect the things that applications live in, the application itself, and across build and runtime both. So that's what we're seeing nowadays. Typically, customers were only focused on build, or rather the run, but the focus has certainly shifted on the build and the deploy side of the equation as well.
Yeah, I think in setting up that build, deploy, run, that also is we're talking about the aspects of using open source and using infrastructure as code. A lot of developers now need to become experts on that infrastructure as well. And I think that's shifting to where our apps are deployed. That's an area for potential mishaps, and just as easy as just simple misconfigurations, not understanding some of the nuances of transitive trust between IAM roles, or the classic case that 5 or so years ago seemed like every other week was, here's an S3 bucket or an Elasticsearch instance open to the internet. So as we start to look at that, that broadening of expertise, no longer can we be just a subject matter on this particular language or application framework. What's the way that security teams can step in and help the developers, DevOps team, to be able to start from a secure basis?
Yeah, it's a great question that you ask. A lot of people who don't have deep security understanding, when they hear things in the news. Obviously, a couple of days ago, we saw a big ransomware attack in the oil pipeline, or obviously the solar storm, a whole bunch of attacks. People think that these things are sophisticated, where somebody's got to use a really incredibly sophisticated technique to breach. And in some cases, that happens to be the case. The reality is that 80% of these problems are just common mistakes, the things that are what I call like really avoidable, silly mistakes that shouldn't happen. As a matter of fact, like Gartner predicts that like 70% of the problems and breaches that you'll see is because of misconfiguration and vulnerabilities, right? So given that context, really where the security teams can help the developers is that, developers don't have the security background. Is to give them the right guardrails, right? Like, for example, you talked about, Elasticsearch instance not exposed to the internet, security groups not exposed to the internet, S3 buckets not open to the public, database instances that are not encrypted. That type of education is required, but that needs to be codified, because if you just tell the developers like these are mistakes, that's not going to happen. It needs to be done in a way where developers can see this on a day in and day out basis, right? As they're building the code in their IDE, they're checking stuff into their source code repo, as they're pushing images into the libraries. The challenges that happen, the security vulnerability as a result of that should be on their faces, right? So the developers know exactly what mistakes they're making. And if they just say like, ignore this warning and commit to production, then they know exactly what they're doing. Because the idea that like somehow security team is going to be able to do all the diving catches across all the innovation that's happening is just foolish, right? It's just not going to happen. The best way to do it is write the guardrails, make sure that you bring security to the developers, not the other way around. And then we've seen a lot of organizations, gain a lot of success by just making sure that there's tooling available as part of the developer CI/CD pipelines.
Yeah, I wanted to tease out a bit more because you said, write the guardrails, write those guidelines. And I think that last part you said is that's bringing the automation of how to do this secure default better than, the old school legacy approach to security that we might have seen 10 or 20 years ago that said, cool, just go through this checklist. Did you do X? Did you do Y? Have you done X and Y? Did you do Z? That they're just some binary yes or no questions that are more reminders to the devs. But now it sounds like we actually have not only the mentality of a shared responsibility, not only with the cloud service provider and the teams, but security team and DevOps building some tooling in there, or perhaps adopting tooling, whether it's open source or commercial. So, but what are some practical ways that you've seen teams be able to do this successfully? And here I'm sort of getting into kind of either an ownership or making sure that these tools are actually being introduced, but so that they are guardrails that enable developers to build the product rather than just being straitjackets that said, we made this so it's restricted that it's secure and automated by default, but you can't really build what you needed to build.
Yeah, so look, in terms of some of the practical things that we're seeing in the marketplace, once again, let's take a quick outside-in perspective on this, right? Traditionally, and a lot of customers still do this, they leverage the SAST and DAST tool, right? Like the static code analysis or dynamic code analysis, right? Which basically scans your Java, your C#, C++, whatever code, and lets you know if there are vulnerabilities, right? And then it's somehow integrated in a kludgy way as part of the CI/CD pipeline. But if you talk to a lot of the security practitioners, CISOs, et cetera, they'll tell you that none of my developers like that tool simply because there are way too many false positives. It's way too bloated, right? Like it gives me hundreds and hundreds of lines of security vulnerability, if not hundreds of pages of document. And like in the modern application environment, that just simply doesn't work, right? Like you can't have the traditional tools doing that. So then the industry said, okay, well, I'm going to go, do something a little bit better. Like with static and dynamic code analysis, it's just way to the left. With dynamic code, like you're just looking at the application from outside in. Then they said, okay, well, let's do IAST, one more technology, but it has the exact same problem. Too many false positives, too bloated, just really not meant for the agile sort of world. So, well, what's the answer then? Because, the Java and C++ and all of that is here to stay, right? So what do you do? What you do is basically take a little bit more pragmatic approach to this. Like we said, scan your infrastructure as code in a lightweight fashion. It'll take you milliseconds to get you the results. It doesn't generate millions of alerts, and none of them are false positives. So that's number one. The second thing you do is, like we talked about, open source scanning, like SCA, software composition analysis is another sort of big area that's come into play, where you're scanning for vulnerability within your open source code. And that's pretty nimble, pretty fast, plugged into all your CI/CD fabric. So that's something definitely we recommend customers to do. There are also other, technologies or trends developing called ASOC, like automated security orchestration, where, you take a whole bunch of speeds and feeds from different vendors, deduplicate it, apply some AI/ML, whatever you want to do, and then it gives you a much smaller result set to sort of deal with that. So that's at the early stages of the application pipeline. And then once the stuff goes to runtime, because the idea that you're going to be able to catch and drop all the bad behaviors early on in the pipeline, again, is wishful thinking. The reality is that developers will say, even if it is fast, okay, I'm going to ignore all these warnings, I'm going to let things slide and go into production. You want some continuous scanning capability at runtime as well, because now the bad stuff is in production, it's running there. You want a tool that's catching that, shining a bright light, so that developers, your SOC teams, whoever can kind of look at it. So hopefully that sort of answers your question. That's sort of more modern way to think about application security. The last thing I'll mention is that obviously once things are in runtime, there are different approaches, right? Like once again, protect stuff that's around the application, your infrastructure. There's microsegmentation, which we can talk about, certainly runtime containers. So, a bad image goes into a VM. You want to make sure that, it's protected against any runtime threats. So that's something certainly, you want to look at. So there are definitely, several tools and techniques from build, deploy, and run that you want to employ. Again, our feedback is, try to minimize number of tools that you have to use to do that, because if you're going to have like a whole bunch of different tools doing all these different capabilities, you're going to have a siloed solution.
Yeah, and I think I wanted to dwell on that aspect a bit more too, because my follow-up question was, that sounds great, but what is the crawl, walk, run, flow here? Because wow, that was a lot of tools that is easily to overwhelm the dev side, the ops side, the security side. So what's perhaps maybe a mentality or some metrics or some success criteria, let me phrase it that way, to aim for, in the sense of what's the risk that you want to go after, or who should be owning these perhaps particular tools, or what's some characteristics of these tools that are going to make them more successful for adoption, that they become useful, rather than, oh wow, I've got to pay attention to 15 different signals from 20 different tools. Yeah, it's a great question. So you're right about one thing, which is that this can all be too overwhelming, because customers are like, cloud is new, I don't have enough skills within my organization, like how can I ramp up and get ready to go? So the first step in all of these things is to gain visibility, right? Like, you can't protect what you don't see. So first of all, you have to understand what you have. So our recommendation is, the very basic and fundamental thing you ought to do is, make sure that you have a tool that gives you visibility into what are the bad things in your public cloud. And let me be very specific. These are all the benign mistakes, right? Like, again, just going back to what I used earlier, applications don't live in isolation. They live in infrastructure, IaaS and PaaS services. So you want to get visibility around all of that, like you have overly permissive security group, buckets, et cetera, et cetera. That's where your journey should start. Understand what's in the runtime. And that's pretty simple, right? Like, the industry has carved out a term called CSPM, Cloud Security Posture Management. You can start there. Once you understand the common mistakes that happen in the runtime, you want to go back. And you want to then make sure that what are the things that's creating this bad behavior? Is it like humans directly going into production, your DevOps teams, or is it infrastructure as code? If it is infrastructure as code, go ahead and have security guardrails up and make sure that these bad things don't happen, right? So it's pretty simple. If you're starting from CI/CD, if you're all CI/CD'd, just fix it here. But if you've collected a lot of debt, you got to shine a bright light on the runtime. That's first. And then the second is that obviously, once again, Gartner said like 70% of the problems are happening because of software vulnerabilities. As a matter of fact, like 42% of the global security decision makers think that the next external attack is going to come because of software vulnerability, right? I mean, that like right there should give you a clue that once you've got the visibility across infrastructure and PaaS layer, the next step is to understand the common vulnerability. Go through the high, critical, then high, and then medium, and then low. Understand where the vulnerabilities are. What are the common mistakes that happen? And then the last thing, kind of the nirvana stage, is that you want a tool or a technology that stitches all that together, right? Like, so for example, because of a mistake at the infrastructure as code layer, something goes into production. If you're able to then say like, okay, well, the database instance that just got created has a known vulnerability, known SSH vulnerability. You're receiving some malicious traffic from outside in. And if you can shine a bright light on that and do visibility and threat detection, now you are going into more advanced and sophisticated use cases. But it all starts with visibility, starts with governance. Then you can go into threat detection, then threat prevention, and then last, the remediation part of it, which is again something you want to automate, right? Like, you can't, if the whole bunch of people in the SOC team are just pushing buttons or manually fixing the problem, you're just not going to be able to do it. You got to have automated remediation enabled for that. No, absolutely. And I think,
Ankur,
go ahead.
Sorry, I want to back up a second. And this is an interesting point, so I want to come back to that, but as well, I'm going to sort of reroute us for a second here. Thinking back to the use case, the way you described through IaaS going away in corporate world and, people adopting SCA. I want to pick your brain. I bet you have some interesting insight on this. Isn't that, in a way, kicking the security can down the road? From the point of view of if you're no longer using I don't know, I always say 4 to 5, but pick your poison, and some sort of static analysis on your code base. And instead, you are looking at the open source packages that you're importing and hoping that you'll are looking for identified vulnerabilities in those packages. Who's scanning those packages to see what vulnerabilities exist in them? So I know from an open source point of view, that's usually fairly difficult. We're all trying to improve upon that. There's all sorts of different projects around that, but what's your take on that? Is that something people should be concerned about, or where does that fall into that overall story arc you're talking through?
It's a good question, John, and just to make sure, I think your question is sort of, how do we make sure that the open source libraries that developers are using, there is a little bit more guardrails and governance around it? Is that where you're going with this?
Partially, not so much governance, but who's scanning those? So is someone running IaaS against those? Or if we do run IaaS against those, is someone actually making sure those issues get addressed? So more sort of, how do we know that the software, because software could have, say, 100 vulnerabilities in it. If someone's only reported 5 and they've gotten CVEs, what do you do then?
Yeah, it's a good question. Look, and I think there is no silver bullet here, right? I think one of the ways you can sort of mitigate some of these problems is to understand the application context, which is really the hardest problem to solve in this. Which is, if you've got whether you're using SaaS, DAST, IaaS, doesn't really matter. If you're going to generate a whole bunch of vulnerability that do not have the application context, you're not going to be able to fix it. You're not going to be able to fix a lot of that problem. So if you have the ability, so once something goes into runtime, to map out the application fabric, what database, web server, caching layer that make up the application, if you have that context, and then if you overlay all the vulnerabilities across that stack within that context, I think you're going to have a much better opportunity to fix the really critical problems. The challenge is not so much that these tools don't generate, vulnerabilities. It's just that they do too many of those. So I think really the need of the hour is to minimize that, reduce false positive, really push through the critical, high, medium, and do it in an efficient fashion that is going to support kind of the CI/CD pipeline. Otherwise, you're going to have thousands and thousands of problems just sitting there. If you survey, and you should ask this question to all of your guests, on an average, how many open vulnerabilities are there in any given application? I think the answer is going to be typically upwards of thousands. And once you reach that level, you can't fix any of these problems because it's just the security teams will freeze. They won't even know where to start.
Yeah, I think for me, what sounds like too is that to try to tie these two concepts together, what John was just bringing up, as well as what we were talking about just before that question too, is that there was that aspect of the legacy approach, the old school approach, if you will, to application security. Let's just have some manual code reviews. Somebody runs a scanner every time every time you're ready to deploy, not every time you're ready to commit. But when you were talking about visibility, Ankur, that was going back to the pretty old school concept of an application asset inventory. Just what do you have? So there are some basics here that are important, and it sounds like where you were going to is that now we at least in the cloud environments, as I like to joke, all of the cloud service providers know how to charge you for the CPU and resources you're consuming, which also implies they should be able to give you a pretty good accurate manifest of just what you have out there for your inventory. But then we have this aspect of where's your application inventory? What's the code that you're using that other people have written? And that's sort of that SCA aspect. But there's also that question of how secure is the code that you've written? And that part of it, we were talking about the infrastructure side. And that was what's really helpful, where there may not be as much expertise on how should the IAM roles be, how about security groups, et cetera, and so on. But then there's also just that application logic. And I think one of the things we haven't really or seen a lot more of now is that huge amount of cross-site scripting and SQL injection that's so pervasive. Yeah. If we see that, it's in those legacy applications. So as we are starting to build this story, this narrative of how do we start to go into just checking our dependencies, checking our configurations, getting those basics down, what are either on the aspect of what are some application threats we should still be thinking about? And here I'm trying to go outside of just the OWASP top 10 classic ideas, or on the other side of the spectrum, what are some better ways we might be able to secure that application layer for the code that our developers are writing?
Yeah, it's a good question. And look, I think one of the big ones that you talked about, obviously, is the OWASP top 10. Again, I think the one of the things that I want to remind the listeners is that it's not always the new types of sophisticated attack. I mean, obviously, there are always new CVEs coming. We all know that. But it's just the form factor. Like, are you able to rapidly detect it? Are you able to fix the problem right away or not? That's where the really, where rubber meets the road. Like, can it really support the modern applications, right? So the problem that we're facing, at least at the runtime, just real quick, Mike, is that the modern web application, like, listening traffic on port 80, 443, HTTP, HTTPS, are very nimble and agile, right? Like, they're living in containers, right? Like, so if you're using the traditional WAF tools to do that, it's just really not going to work, because it's got to be really fast and nimble to detect the typical cross-site scripting, SQL injection type attacks. So you want a solution that basically is protecting your web app against the modern day attacks. And by the way, the one that's big, obviously, nowadays is API protection, right? Like, I mean, APIs are pervasive, it's everywhere. Botnets, right? Like, especially with e-com, like, I think we're seeing a lot of botnet attacks. You talked about OWASP top 10, so that's something obviously we have to do. And then some of the things that we're hearing quite often now that Dogecoin and Bitcoins are on up and up is rise of the crypto mining. We're seeing this. I would say like once a quarter, where like we see hundreds of containers being spun up in customers' environment, and they're used for mining crypto. Right, so you want to make sure that you've got solutions, threat detection solution that's protecting your applications against, and they can hijack your compute and then use it for mining crypto and other types of malicious activities. So again, the fundamental building blocks of what needs to get solved remains the same. I think the form factor, the environment, the infrastructure, that changes quite a bit, and that's what we recommend customers to have to pay close attention to.
No, that makes sense. I think, one other part that I heard in there too was, I would kind of highlight as a metric is that how quickly, what's your speed to fix? So what's your metric either in the how quickly can you find one of these vulnerabilities, and then something you can influence on your developer side, how quickly can you fix something? And I think that's probably as long as we're fixing that something is a real bug or has a security impact within the context of the app, that would be I think always a good metric to strive for. So want to wrap up here a little bit, just kind of turning our focus toward the future. And you were just mentioning a couple recent types of attacks that we've seen more of. Even a lot of the free services that provide CI/CD capabilities, they're shutting down a lot of the free capabilities because that compute is being misused, being abused. And there's a lot of inauthentic behavior against from bots on a lot of APIs, on a lot of, especially where can you make money in carding sites, things like that. So what does the future look like in this crawl towards either too many tools, we're getting down to fewer tools perhaps, or that idea of making deployed code more secure or deployed environments more secure?
Yeah, great question. Look, I think the model for the future already exists, right? Like, and this is, obviously public knowledge, but what Netflix does, for example, right? Like, as part of their CI/CD pipeline or as part of their infrastructure and Chaos Monkey, I think that's the nirvana, right? Basically, all applications, all the infrastructure, everything gets built through the CI/CD process. No humans have access to the production environment. Everything is completely secured and buckled up. And then they're running continuous scanning across build, deploy, and run to ensure that every time there is a change, they can go back to the gold master known last good state, right? Now, it sounds simple, right? Like, I mean, that once you have an approved infrastructure as code template, once you have an approved set of packages, Why would a mistake happen? Well, the mistakes typically happen because the organization are more and more decentralized. So everybody's going to use their favorite tool and technology to solve a lot of these problems. So in my opinion, the future is where customers have a standardized kosher IAC that is only used to deploy the infrastructure. Nobody else can do anything else. All IAM rights are taken away from public cloud. And obviously, I speak specifically of public clouds. I also then see that all the high vulnerabilities, customers have sort of embraced this notion of like, okay, well, what is a risky behavior? What is non-risky vulnerability rather? And as part of their CI/CD pipeline, anything that is super risky just never makes its way into production, right? It just block at the early onset, right? And finally, I mean, I as an industry, right? Like I come from the industry side, obviously. I think we typically have done a disservice, the industry in general, for our customers by having like many tools. I think what customers need is a single consolidated platform that can support the app or that can secure the application across build, deploy, and run. So a single tool, standardized processes and practices to secure your application all the way from developers, IDE console, all the way to your production runtime, be it in Amazon, Google, Azure, whatever that may be. If customers are able to do this, I think I fundamentally believe cloud makes applications more safe, not less. And it's a controversial subject. Most of the customers don't go to the cloud because they're afraid that things will break. Actually, we should get customers to embrace more and more cloud. It's just that they need the right tools and technology. Obviously, at Prisma Cloud, we do a lot of that stuff. But I just want to encourage customers to look at cloud, figure out a way to automate security all through the CI/CD pipeline.
Well, Ankur, you've given us a good consolidated, solid half hour to talk about these the past and present future of AppSec and infrastructure as code. I want to say thank you for that chance to come and speak with us.
Yeah, thanks a lot, Mike and John, for having me. I really enjoyed the conversation, and we'll speak soon, sometime in the future.
Fantastic. Thanks again, Ankur. I want to thank John as well, and thanks to everyone who's listening. If you'd like to learn more about Prisma Cloud, visit securityweekly.com/Prisma Cloud. We're going to take a quick break now and return with news of the week.
Cloud-native development presents new challenges for security teams. Ephemeral workloads are scattered across services, and it's hard to identify resources, monitor configurations, and ensure compliance. Prisma Cloud by Palo Alto Networks is a comprehensive cloud-native security platform, delivering full-stack protection for multi- and hybrid cloud environments. It provides deep visibility, threat detection, and data security, as well as protection for hosts, containers, and serverless while enforcing policy guardrails. Visit securityweekly.com/Prisma Cloud to gain control over your cloud security. Uptycs has built a platform for SQL-powered security analytics. Extending the OS query agent, Uptycs collects, aggregates, and analyzes a wide range of system data and makes that available to solve multiple security challenges. Their solution provides visibility across Linux, macOS, Windows, containers, and cloud workloads. Their customers are using the Uptycs platform for fleet visibility, intrusion detection, investigation, and audit and compliance. Visit securityweekly.com/Uptycs and be one of the first to see how they've mapped over 500 behavioral rules to the MITRE ATT&CK framework. Whether you need to manage bots, protect cloud applications at runtime, stop form-jacking attacks, or secure your web applications and APIs, only Imperva offers a unified solution to protect from edge to application and data in one tool. Imperva helps you achieve more, save money, and become more efficient with fewer security vendors needed. Start a free trial today to easily protect your apps and website with Imperva. Learn more at securityweekly.com/Imperva.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella. Security Weekly listeners save $100 on their RSA Conference 2021 All Access Pass. RSA Conference will be a virtual experience from May 17th to 20th, and Security Weekly will be live streaming that Monday through Thursday in the virtual broadcast alley. We'll be interviewing some of the top sponsors and speakers for the event. To register with our discount code, visit securityweekly.com/RSAC2021 and use the code 5U1Cyber. We hope to see you there. Do you have a specific guest or topic that you want us to cover on one of the shows? Submit your suggestions for guests by completing the form at securityweekly.com/guests. We read suggestions monthly and we'll reach out to you once reviewed. Take a breath now. Now, as listeners may be aware, I tend to harken back to the 80s or perhaps a bit of history. Today, John, I wanted to go back 20 years to May 2001 real quick for a double decade about a double decode vuln. This is like the ... It's sort of a Morse code for my favorite vuln. And just wanted to kind of highlight this as an example of what the CGI file name decode error vulnerability looked like and what web application security looked like 20 years ago, and perhaps ask what has changed and what hasn't. I'll say really quick on a positive aspect rather than harp on the bad side of things. The double decode and then code red a few months later in July of 2001 hit IIS pretty hard. Then came along the Bill Gates Halloween document, Trustworthy Computing Effort. And actually since then, IIS had a very strong story about security. So even though we are talking about one of my favorite vulnerabilities of all time, it did instigate what was actually, I think, overall, a kind of a success story in terms of hardening at least one particular code base within Microsoft.
Yeah, it took them a while, but they ended up really sort of nailing it, like you said. This one really scared me, though, when I saw this in the show notes. And I clicked on it, and it's funny because this is I think one of the original posts. And I'm like, BugTrack? I haven't seen anything from BugTrack in a while. Am I missing a mailing list or something? And I looked, I'm like, IIS CGI what? And yeah, no, I just finally saw the date on it. It's a lot has changed. And it's funny, I think recently we mentioned somewhere around here, web shell scripts, right? Which is still sort of either a CGI or a PHP-based thing, which these are still sort of relatively CGI-based, depending on how you're using PHP. But happy to see, a lot of things have changed. I hope a lot of the stuff that we were talking about back in this point in time, wherever we were in the world, has been updated a little bit and become a little bit more secure, but there's still a lot to fix, as we've seen.
Still a lot to fix. And I will say, too, and aside from the nostalgia, the trivia of bringing up what happened, 20 years ago this month. What you hit on there, the web shells. This is one of the other reasons I like to bring up these ideas of the directory traversal, because if you look at some of the flaws here, there was write access to the document root. So attackers could upload arbitrary content. They could read access to the file system, or in the case of IIS, whatever volume the service was deployed on. And you could actually execute a command shell, either the one that you uploaded yourself as some ASP code, or you could hit the cmd.exe. So all of those aspects actually have a lot of hardening steps that could have been made better. And we see, I think, some better aspects of that when we talk about containers, isolation, removing the ability to call it like living off the land type of attacker techniques. So even though, going back in a bit of history, I think there are still a lot of lessons for modern applications. And that is another reason why I want to try to bring it around, make it relevant to see what have we learned and what still should we be learning from the sins of the past.
I think that's a good point. And, we just had Paul Walter guys on, specific guy, but we've I think where a lot of us as an industry have, at that point in time and since, we realized we're not going to be able to fix all these issues. So what can we do to isolate? Like you mentioned, containers. Not full security isolation, but we've made all sorts of leaps and bounds around this. Like back in the CGI days, I think one of the first things I remember them doing, at least like for PHP, was to put each requests either into a separate process or a separate thread to try and minimize the cross-contamination. And we've done a lot of things on that side, which I think has been really helpful. Cloud wouldn't exist the way it is today right now if we didn't have some isolation between and allowing multi-tenancy. But yeah, it's whack-a-mole, right? We fix one thing and then something else either pops up or we start focusing on it more than we did before because the bad guys realize, hey, well, that stopped, so what else can we do to get in there?
Indeed. So I think now, though, let's switch gears from the ancient history of web application security into something that's actually quite more modern. And it might have some parallels in protocols and such, but AirTags. So AirTags, definitely in the news recently because Apple just had some big announcements about all of the new Macs, the new iPhones, the new capabilities, including AirTags that are coming out. I think it was just last episode we were, or an episode or two ago, we were talking about a write-up about AirDrop and some privacy settings and the protocols around what the AirDrop protocol can reveal or not reveal, for that matter. In this case, there's a lot of focus on AirTags in the sense of what are the threat models around them? And there's a couple things that I'll just kind of seed here, and then we can explore from there. One is that Apple has done a pretty good job of explaining some controls around what happens if you have a lost or a not so lost, but a placed AirTag about you or on your person. It will actually start to beacon out, but it will only beacon out after a couple days, 3 days right now by default. And it's primarily going to be part of a threat model that helps you if you're within the iPhone ecosystem. So you could still use an Android phone once a AirTag is in lost mode, and you could tap and see where it's lost, who it belongs to. But a lot of the warning, a lot of the, to be clear, anti-stalkering aspects right now seem very focused on a long time frame and focused on you have to be on the latest iPhone, iOS, and be within that ecosystem. So I think these are some pretty understandable concerns, and it's kind of interesting to see what this type of new technology and new use of technology is creating in terms of threat models and the application and the product security discussions around it.
It's well, first, you mean we're not going to just talk about drilling a hole in an AirTag because we're too cheap to go and buy an actual keychain? Now that I got that out of the way, I've got friends doing that, unfortunately. And hey, nothing wrong with it, but it's, at least to me, there's something wrong with it. I think the interesting thing here is for a company that's so good at controlling their messaging and what they put out there and thinking about privacy, this seems like a fairly big slip. It'll be interesting to see, just purely from a messaging and marketing and business point of view, over the next 6 weeks, how this changes. I think it was on Apple's radar, and that's why there's been a little sort of, that 3-day period, as you said, can change. Unfortunately, it changes at Apple's will, not at everyone else's. So we'll have to see sort of how this evolves over the next month or two. For a lot of people, that's a really huge deal. And also, sort of vaguely related to this, I think we're going to be talking a lot more about Bluetooth over the next few weeks too. So there was another announcement out. I believe it's Amazon's Sidewalk network, which we've covered briefly before. They're expanding that so that Tile and some other guys can go on there. And then I think there's one more of those mesh networks out there. But anyways, there's more of this stuff coming. So as the bad guys think and ponder around what they can do with this, we're probably going to be covering this more.
I think so. And there's a lot of fun angles to cover on it too. As I was reading up on some of the ultra wideband specs and et cetera, and the technology behind it, it was pretty fun because I was dusting off some of my own EE background and talking about antennas and radiation patterns, et cetera, and some of the modulation techniques that are used just for these at the physical layer for these devices to connect to each other. But to kind of bring it around to either AirTags or just, Amazon Sidewalk as you're describing, there's also a lot of the aspect of the pervasiveness and the how far-reaching these aspects are. So, for example, I think the Tile has similar tracking, little gadgets, but that's on the order of magnitude of, I think, a few dozen millions. I think maybe 30 to 40 million in terms of adoption. Whereas if you turn to Apple's massive ecosystem, you've got roughly 1 billion devices out there that could be, even with a privacy-preserving mode of individual phones detecting individual AirTags. You don't know which phone identified which AirTag. Their identity is mutually concealed from each other. But it could make it quite easy to have a far more reaching ability to drop an AirTag onto someone and follow them far more than a few hundred feet into a matter of miles, a matter of, a full citywide tracking. And I think that is sort of the scale of this is one of the big things that definitely makes this different. So it's it's going to be an area that we talk about and we pay attention to for quite a while, I believe.
Yeah. Yep.
There's also some things that we'll be paying attention to in hardware and firmware, because not only did we have some, Apple AirTag teardowns, I threw some links in there in addition into the show notes. There was also some research onto some Qualcomm phones. And so this was looking at a system on chip. So this is a system on chip modem used to manage basically the radio layer on a lot of any Qualcomm devices that are using this chip. And what some researchers from Checkpoint did is poked around at it, and rather than try to attack the modem from the radio layer in terms of trying to get some fancy SMS or getting into their software-defined radio to try and spoof or play about with the protocols it's receiving, they went from the Android layer. And they were successful, found a heap overflow that essentially turned into the ability to say, we can bypass the integrity checking that's part of Qualcomm's trust zone enforced by the chipset in order to basically run some arbitrary code that could inspect SMS, which for those of you thinking of OTP challenges in MFA, there's one threat right there, as well as it could get into voice, etc. So pretty interesting there. And I think the one other thing before I run out of breath as I'm describing this is that it will be interesting to watch here in the sense of how does this get patched, both in the question of am I vulnerable and do I need to get patched? Because we're not looking at the Android ecosystem so much as the Android device ecosystem. So it's one of those challenges of application security is in the sense of where do I go for the patch and how do I make sure my systems are patched and up to date?
Yeah. It's one of the tricky things once we start having, so this is the radio socket, still not the main sock on these phones, I believe, right? You're still going to have a whatever else, a M4, what have you. Excuse me, a A4, A7, A9, whatever they're up to nowadays. But so the reason I mentioned that is, think back to like Intel TXT or Intel ME. These things which, as they're not the core main CPU, they're not getting as much security attention because that's not what we're interacting with or what we think we're interacting, right? We're definitely interacting with it a ton because that's your communication center. But glad you mentioned the patching aspect. That was in my mind. I was looking at something over the weekend. I think it's a knockoff version of, a compatible version of Philips Hue lights. which sell for a fraction of the cost. But one of the comments in a review which caught my attention is this thing going to be patched in the firmware kept up to date, like on the main product? And in that particular case, I guess the Philips Hue hub will manage firmware updates for the Philips branded controllers, which connects to the hub, but it ain't going to do that for third party. So not quite a direct relation here, but still that idea. If you go for maybe a cheaper phone or a phone that doesn't have a really big name brand radio in it, is it going to get the same level of security support? So that's interesting to think about. Probably not as big a deal in phones, but still definitely interesting to think about.
Still good to think about. And I'm glad you pulled that in too, because here I was looking at this and thinking of that software bill of materials sense of just what is composed of this. If at least that would give us a way of asset inventory from the user's perspective. But I don't know that there's much there. But it's more of just what is the security cost of having an outdated phone, or in the sense of, do I have to buy a new phone or do we, can I get a patch somehow? So good point. I guess that's the best I can say, John. Very well done. I'm going to use that to talk about one more firmware aspect. And this is actually more of a device driver that's used to update firmware. But this was another security researcher playing around with some Dell hardware, Dell device drivers. And this one just kind of stood out on two particular themes. One, we talked where this episode is hitting on a bunch of sort of that hardware firmware side of things and flaws with long lifespans. So in this sense, here was a researcher who found some vulns, and these vulns had been around for, or at least affected software that's up to 12 years old. So it kind of hits that I think is kind of what you were describing just now, in the sense of IoT, what's the support lifecycle from either from the main provider or that third-party environment that itself, or a third-party provider. So not so much interesting here in terms of Dell, et cetera, and so on, but just that sense of device drivers, long-standing vulns, and to try to tie it back. We had talked back in episode 147 about Linux kernel moving in adopting Rust in its code base, Rust, of course, being a memory safe, and that property being a desirable aspect to use it rather than C. And device drivers have been a notorious source of insecurity. So I think this, is a bit tenuously related to Dell, the Windows ecosystem, but in the principle of what an attack surface look like and where our, prominent threats are, this kind of reinforces that good choice to say, let's do something different in the way that we're writing our code.
Yeah, you just reminded me. One of my problems the last few weeks is during the weeks I'll get stories to cover on the news here, and I'm not always getting them into our news queue. And one of the ones that hit me last week was I think it didn't quite rank well enough to get mentioned, but I guess now it does. It looks like the malware authors are starting to rewrite some of their malware in Rust. Not so much from a security point of view, but because it looks like, and there wasn't enough meat behind the articles, probably why I didn't put it in there, but they're rewriting some of their malware in Rust, and they're finding that it's actually harder for the AV systems to detect it. So interesting, right? They're looking at it from security, but from a slightly different point of view. But back on this article, it's a good write-up. It's like, both of us, we're fond of these meaty write-ups to start looking at device driver code levels type stuff. So this is good from that point of view. Honestly, when this came out last week, I mostly ignored it because I'm like, oh, yay, another Dell firmware update. I guess It's been a while since we've seen them, and this affects a ton of machines, but as you said, Dell's support's pretty good once they admit there's a problem. Didn't mean quite so snide there, but is what it is. So yeah, it's a big deal. I know there's a lot of people I heard over the weekend that are scrambling around trying to figure out how they're going to deal with this. And it's, again, the device drivers come back and bite us.
They will. And in a confluence of events here, if you go back and look at the article, look at the disclosure timeline here. There was one comment from Dell that says no patch will be available or they're not going to bother patching one of the vulns because the software is deprecated. And I think that goes back and speaks to just what you're saying about the IoT environment. Will we get patches? Will they be backported? So important questions there. And I think that's going to give me a chance, talking about backporting patches and the long-lived vulnerabilities. I pulled out a article about XSIM from Qualys. Now, we talked about this back in the fall, I think August, September, I can't quite remember, of 2020, when these vulnerabilities were first announced. But I wanted to revisit it because Qualys updated their blog post, talking a bit more about it. Near the end, it becomes a bit salesy, but at the beginning, some of the things that stood out was that these vulns came out of a, quote, thorough code audit. And to me, that kind of speaks to the idea that, yes, we do like, as application security practitioners, seeing code audits, whether they are done by humans, manual code audit, or done by SaaS tools, DAS tools, or SCA, depending on what angle you're hitting, code written by others, code written by yourself. But these vulnerabilities reach back all the way to 17-year-old versions of XSIM, and yet nobody had found them until Qualys had these researchers dove in and took some good scrutiny there. So it's just kind of pretty interesting in the sense of not so much nihilism that we can't find everything, but a good reminder that humans aren't necessarily great at inspecting code. So we do need some automation to back it up. But clearly, over 17 years of automation for a popular open source application like XSIM, we need some smart humans to look at that code as well.
Yeah, I mean, these guys, it's always fun to see the write-ups from Qualys. It's a sharp group of folks there. And, this is, what was it, 3 episodes back, 4, where I was saying, don't run your own mail server? I hate to bang on that drum, but let's see, you just said, another thing I've been reading, and again, it comes back into what we were just saying about how do humans do code review on this type of stuff. There's a stat out from, and it's not new, from the guys over at SmartBear. They do Swagger and a few other things in that sort of application management and documentation and security space. But they've done some studies with Cisco and some other orgs showing that if a developer or a code reviewer is going to be optimal, they shouldn't be doing code review for more than an hour, and they shouldn't be their rate of review should be less than 400 lines of code per hour. So I thought between those two, that's pretty interesting, right? I don't remember the spec we used to use back in my professional days when we would be building quotes for what it would cost to do a review. But I'm sure when I'm going through code nowadays, I'm guessing it's at least double that. So now I have to go and check, because I'm usually just ripping through quickly. Mm-hmm. But that's sort of something for people to think about. We talk about code review, but what does that mean? How fast do you go? What do you actually, depending on the speed you're ripping through there, that's going to change what you find. Are you looking for the big obvious things, or do you focus down on something particular? What do you look for? So combining that with this is sort of, that's how we find these things, or how we stay secure. So it's still important.
Still important. And speaking of finding these things, one of the other sites that I mention every few months or so is the cyberitl.org. And they're pretty neat, because they took an approach to say, what are the ways of hardening the software once it's built? Basically, compiler settings of the binaries. And they were focused on operating systems, on browsers. So consequential areas of attack surface. They're recently, I think, looking at smart TVs, but they haven't updated a lot of their research. But they just recently released the static analysis tool that they use to behind their methodology for saying how hardened is this binary, in the sense of having ASLR, 64 bits, et cetera, et cetera. And the reason I brought it up was I would love to see more of this applied to the modern operating systems, just to get feedback. It'd be great to see this type of hardening review applied to the IoT space, as well as, perhaps more importantly, the industrial IoT. That's that sort of angle. And we've even seen in the last couple months, I think it was F5 had a vulnerability where stack protections wasn't even enabled for it. So these types of very simple hardening are still being missed. So I just kind of wanted to throw this in as a tool that kind of helps complement the manual code review that you were just talking about just now.
Yeah, it's Sorry, I made the mistake of getting sucked down. I'm looking for an ASMR joke to throw in there, but I'm getting distracted. One of these days, I'm going to have that joke.
Next up, John Kinsella gives us the ASLR speaking.
I'm telling you, there's something there. No, these things are. I think I have become so used to using the commercial tools, again from the past life, that I don't give these open source ones as much credit as I should. I mean, I'm using GoVet on a weekly basis, particularly security modules in there, but still, I don't look at I tend not to think of using these tools as often as I should. They've improved so much over the last 2 or 3, 5 years. All these guys are doing a ton of good stuff, so it's highly recommended for people to, if you need something in this space. I mean, obviously you have commercial support and all those type of things, which are very valuable, but at least take a look-see at these when you're going around looking at for either static analysis or fuzzing or any of these areas. And I'm looking at the commercial tools there as well, but it's definitely worth at least spending some time looking at state of the art.
It'd be neat to see that, and especially too, we've seen state of the art improve with iOS and pointer authentication codes, also helping additional countermeasures that could be really strong here. So be curious to see that unfold more. And I'm going to come back to some compiler discussion, but first I want to throw over to you and talk about some maturity models. So let's step back from a little bit higher than just talking about in the weeds of hardware, firmware, and compiled languages, and maturity models for Kubernetes. This one stood out to you.
Yeah. So after this, we'll get back to talking about bytecode optimization, right? So this I'm putting this in here. I'm looking for feedback from you if you've read through this, or from our listeners or anybody. Because while this is interesting and it caught my attention, I'm not sure I agree with it. And again, when I do this, I've done this recently with the VC making some silly statement, which we both agreed against. But I'm not looking to chew on a vendor. I'm really looking to sort of go, is this the state, or how can we improve this or help improve, or what does maturity look like? So what this is a blog post. Let me back up about the Kubernetes maturity model. So when I think about that, and again, I'm someone who's used Kubernetes now for 5 years. 4 years? It's been a while. So I think probably, I'm trying to, I realize I'm in my bubble. I'm trying to sort of look outside my bubble here a little bit. I'm a little teapot. Anyways, sorry. Coffee's kicked in.
Embrace
but
it.
So looking at what they've got here from phase 1 to phase 7, prepare, transform, deploy, and I'm ripping through these. Build confidence is phase 4. Improve operations, measure control, and then optimize and automate. So phase 1 and phase 7 I agree with. I guess when I think about Kubernetes maturity, there's 2 ways you can think of this, right? One is the first time someone's coming to this, and how do you actually climb that mountain, slab of granite, and get into this, versus as you become, I suspect where I'm going, what I'm thinking about this, I don't think it's a linear path. I think this is a non-linear curve. And it might be, it's going to be that way. So it's
sort of
inverse. It's going to be inverse exponential, right? 1 over e, I think. Anyways, 1 over e to x. But so I guess where there's a really steep initial learning curve here. I mean, the way they talk about, I think this is, and I went and looked at Fairwinds, and they do Kubernetes stuff. I was looking to see if they were a consultancy, which I don't see, because this feels like this was written by someone trying to sell consultant work. Prepare, obvious, we get that. Transform. So I guess from where I'm coming from, and where I'd love to hear feedback from others, is these first 2 or 3 phases I would consider all phase 1, right? Until you've actually done some type of deployment, you're still at phase 1. I mean, thinking about, I don't know, I'm having a little bit of difficulty here, and maybe it is just there's not 7 phases, there's 5, but stretching that first piece into 3 phases seemed like and then build confidence. I mean, that's something that's always ongoing, right? And I think, you know what it was when I was thinking through my sauce last week, the first time I use Kubernetes, or I think most people do, you're either doing kubectl run or kubectl deploy, right? So you're just get something out there and running. And then as you get more sophisticated or more mature, at least in my mind, you start using Kubernetes YAML, then you go use a Helm chart or Kustomize or one of these, IACs we've been talking about. And then as you go through more maturity there, you're building out, how do you secure this? How do you secure the application, the IAC? What operations? I think that's sort of the core part of using Kubernetes, right? Is you're not going to be, if you're deploying this stuff by hand, you're really low in the maturity scale. So I think what they put as 5, I'd put down as like 2 or 3. Measure and control, again, I think that's a core part of a cloud native environment. So maybe it is something you're going to get to. And I think what could be going on here is Phase 7 goes on for a really, really long time. But I would expect, I think most Kubernetes platforms now, Kubernetes deployments come with some sort of monitoring and measuring and introspection capabilities out of the box. So if you're waiting till Phase 6 to use those, that's sort of interesting. So I don't know. I'd love to hear feedback from people. I could be off my rocker. I haven't actually tried to, write down 1 through 7 myself. I'm just sort of talking it out loud, but still interested to think about one way or the other.
Yeah, love to hear some feedback in our Discord channel. Come by and let us know what you think, or if you've adopted a slightly different model. And my initial reaction was, I think, similar to yours in the sense that phase 1 through 4 sort of seemed just like collapse them into just that initial step of you're doing everything manually, then you're starting so that you have an idea of here is what we're building, here are some security guidelines we want to make sure we're doing. So you're sort of thinking of it as a manual checklist, and you're doing it manually in the sense of running command line tools. Then you're maturing in the sense of, as you mentioned, YAML, and then you're building, having that maturity tying the implementation and automation of your security controls or your security standards becoming code. And then you're starting to measure and say, how are we doing? Does this make sense of what we're doing security wise, how we're automating and enforcing the control of it? And then ideally you're getting to the end where you're starting to get to the point where you can say, we've done some neat configuration. We have some default baselines. What can we do to innovate on top of this? And that might be some more advanced tooling. That might be some more advanced mesh networks design, peer-to-peer, service-to-service authentication, those types of things. So there's some seeds here that I would think myself I'd use a maturity model, but it doesn't resonate as strongly to me that I would follow it in this particular order. But talking about following things in a particular order, did want to end here on a pretty technical article, but I think I can pull us back into some security angles here. So this is a neat blog write-up from Cloudflare talking about a conditional an if statement and how optimized can it be. And the thing that came to mind here in the sense of this article was one, it's really neat, really well written and accessible. So those of you who are interested in Spectre style of attacks or what's going on within the CPU, check out this article. Really, really neat. But the other thing that stood out for me is that for me, a message here is in your code, aim for readability, which means readable code becomes more maintainable code. Rather than trying to think you have a clever optimization that the compiler doesn't know about or trying to outsmart the compiler, write some code, let the compiler optimize, and then move on from there. So that was sort of the thing that I was thinking out of when I was looking at this too. And the sense of what is my security hat in interpreting this as. So I don't know if there's something else that stood out for you in this particular one there, John.
No, I've had some interesting thoughts around optimization recently, and I'm not quite bored enough to always go down the path. There's another vendor out there that I'm going to leave the name out for now. I've mentioned it before, but they sent a pull request over to my day job's open source project, Accurix Terrascan. And what it was their static analysis tool had found there was a potential issue with string comparison. And we really nerded out on it. And I might have talked about this podcast before. I can't remember if I did or not. But we really nerded out on how does the Go compiler actually break that down, that string comparison. And it turned out that either way you did it, either the right way or the wrong way, the machine code looked the same. So there's a website out there, people can go Google, that will, it'll, you punch your Go code into one side, and then you pick your platform and your Go version, and it'll actually show you the compiled bytecode. So, or machine code. It was really neat to go and look at that. But why I'm bringing that up is there's been a few times recently where I'm either writing code or doing a code review with the team, and I'm looking at something, I'm going, well, that looks like that might not be the best way to say, for example, do a for loop. Actually, it's sort of similar to this, right? And I'm like, okay, how is the optimizer actually going to deal with that? So I think this for folks who aren't familiar with the way a modern compiler will optimize the bejesus out of some of this stuff, I think it's a pretty interesting read. It's a heavy read, but also it's the question comes down to, when do you actually care enough to be nitpicky and looking at this, and then how do you go about figuring out where the slow code is that you need to work on optimization. So that's sort of the way I think about it. Like, it's, can I throw a profiler at it, figure out, what's taking the biggest chunk of time, and then go and see what's going on in there. Is it a memory thing, or is there some loop going crazy that we could short circuit after a few calls or a few iterations? So this is interesting from a lower level, and I think it's a good read just to think through. But as usual, at least for me, it's bring it back to how does this relate to your day job and the type of code you're working on, or your team's working on. I think another interesting aspect here could be, if you are on the security side of the house, if you're looking to make recommendations to the dev side from a code point of view, or even from a library point of view, what does that do to performance? That's sort of, we've talked before about embedding security into dev, or we've taught about the other way. But that's one way to think about it. It's like, if you're going to make a recommendation that you should be checking for a null value at the end of a string, what's the best way to do that doesn't slow down the application, is one very generic example. So I think some of these things are sort of, it's a good read. It's a meaty read. We've got two of them today. But, think through in the back of your head as you scan through this, how does this relate to my team? I think that's sort of a fun experiment.
I think that, and that's a great point. And the other aspect that you were really hitting on there too is bringing data to the discussion. You're running, looking at something like Valgrind, where when you're profiling the code, where does it actually show it's slowing down? And what was surprising to me in particular from this article was how things varied amongst all the different chips that they were running this on, including what was really neat to see that, the Apple's new M1. So some really cool ways of looking at metrics. And I will say, so I don't be completely dismissive of, from a security perspective, talking about optimizations or not worrying about the compiler, there are situations where you want to zero out a memory space. For example, you've used an encryption key or some other secret, and now you want to clear it from memory. Zeroing out memory is something that often can be optimized out, and it may not be cleared unless you're using some very specific codes to do so. So always a lesson learned. And so I think in that we've definitely spent more time on the deep hardware, firmware, and software that will last us for once in a lifetime. And I wanted to bring us back to some Talking Heads reference. And I also just want to say thanks everyone for listening. Thanks again, John, for joining me and talking through all these articles. We will see everyone next week on Application Security Weekly.